Oh no, I'm trying to procedurally generate terrain but don't know how to give it a smooth outline. Whatever will I do?
It sounds like you need the revolutionary new technology known as marching squares.
But what is a square? And why are they marching?
Did you just ask what a square is?
Well, Jimmy!
Okay, but actually, what is marching squares? See, it's just this line of code right here, that one line. You just ignore the march. It does it for you. I'm joking. You have to set up march yourself. I normally call it march, but you don't have to. You can call it anything you want. You just need to make sure you know what it is, and you need to pass it an array of points, which can either be true or false, or what I normally do is 1 and 0, because it's significantly easier to type in a lot of 1s and 0s than it is to type in a lot of trues and falses, because it's a lot less characters. And what you do is you need to choose what's known as a starting node, or like a control node. I don't know its actual name. I'm just making stuff up as I go along here. And that is what you base all the calculations off of for each like chunk of the shape you want to draw. But each master square does have 3 they can read from. I normally do the top left one, or starting at 0, 0, because it's an array. Array start at 0, 0. You can do it otherwise, but I wouldn't recommend it because it will just cause you a lot more pain, because you can't start at 0, 0 like a normal person would. But if you pull that out, you have the master node, the first node, the second node, and the fourth node. Now those names might not make any sense, but here's what they mean. The first node has a value of 1, obviously, so we call it first node. Second one has a value of 2, so I call it second node. Third one, intuitively, has a value of 4. Not intuitively, but it does. That's the fourth node, and the master node has a value of 8, which you haven't noticed is a nibble in binary. That's what it is. It's a nibble. It's 4 bits, half a byte, a nibble. Now that means it can add up to 16 because binary. That's just how it works. I don't know how I'm going to explain that if you don't know that. It just does add up to 16 if you have them all on. Now this means these 16 different combinations go from 0 with none of them on to 15 with all of them on, which is like a full chunk, which is the inside of the shape. Now what march actually does is it calculates the marching value. I just call it that. It's not actually called that. I don't know the actual name. Google it if you want. It takes the control node, right? And if the one below it is on, it adds 1. And if the one below it and to the right is on, it adds 2. If the one just to the right is on, it adds 4. And if it's on, it adds 8. Which then allows all the combinations to be calculated. There's 0, none of them on. 1, which is just that. 2, it's that, but on the diagonal there. 3, it's the whole bottom row. Crazy. 4, diagonal on the top one. 5, 4 and 1, just like that. You don't see it that often, but it can be there. 6 is 4 and 2, so just that side. 7, I love counting, is just that, skipping out the top right one. 8 is just that one, obviously, so it's just a corner. 9, 8 and 1, it's another one that's just the sides. 10, it's another one of the rare little diagonals. Don't see them all often, but they exist. 11, just that one. 12 is 8 and 4, which is the top one. 13 is 8, 4 and 1, which is one of the other, like, 3-point ones. I don't know how to describe these. I'm just going to put them up on screen. And then there's 14, which is 8, 2 and 4. And finally, the big 15, which is all of them and fully on. Whoa! And you just have those in an array, so you can then pass in the values. Now, I've just described an array of sprites and how to calculate a number. But what does it all mean, Basil? Well, if you take the numbers, shove them into the array, every single point will then have the correct sprite, because that's how arrays work. It just pulls it out and then uses it. And then you do that for every point, except for the ones on the end of the x and y axis, because if you're using from 0, 0, they will break. They'll make your code go oopsie. It will breaky. It's a big bad. Don't do that. One of the most common applications of this is if you've ever played a city builder game and you've placed down parts and they're formed like a coherent shape. That's marching squares. If you've ever seen a procedural item generation in like a pixel art game, that's probably marching squares. I've used it like that before. But what does it look like in practice? Well, you can press these little nodes. I made them visible so I can click them easier. And then those draw little shapes. Oh, that's a cool one. I don't like that one's ugly. I don't like that one. Can you get off my screen? Thanks. Obviously, this isn't the only things you can do with it. You can do it on a bigger scale with 3 points on each edge and one in the middle. I don't like doing that though because it's just way more complicated, and you can achieve the same effect by just using like 4 times the squares. So I normally do that because I'm lazy, even though it runs slower. Now, bringing all that back to the original line of code, you have what you're setting the sprite to, the array containing the set of the sprites you're going to pull from, and then you have the march, which we've already done, which then calculates the number, puts it into the sprite, and then displays it. Bada bing, bada boom. Marching squares. Okay, bye.